It's great to be here today. I'm Joshua Prisbilko, Head of Product at Kumo AI, creators of the first foundation model for relational enterprise data and leaders in graph transformers for predictive models for the enterprise. Today, I'll share a quick look at how Kumo AI brings predictive intelligence directly to your Snowflake data, with no model training, no feature engineering, and instant predictions. Our predictive intelligence agent can deliver forecasts, risk assessments, recommendations, all at the moment of decision. We'll even dive into some code to show how this works under the hood. To stay competitive, businesses need predictions, not just insights. Predictions that are accurate, explainable, and grounded in real data, and accessible to everyone throughout an enterprise at all levels. Predictions need to plug directly into your data without complex feature engineering or complex ETL pipelines. In the age of agentic AI, we're moving beyond reactive dashboards or reactive business intelligence and static models and CRUD-based UIs into the age of predictive decision intelligence, where predictions are surfaced at the time of decision. Now, you might think, can't LLMs do this? Well, not quite. They struggle with structured data and the semantics of relational data. Folks have tried. We can pass relational data from our data warehouse into strings and feed it into the LLM, as we have done here on the right. And we have done this several times. And unfortunately, LLMs just cannot make sense of this mess. You're going to end up spending a lot of money with very poor outcomes. This is where Kumo comes in. Built on graph transformer technology, our foundation model turns your raw Snowflake data into instant explainable predictions. It uses a simple predictive and flexible query language that can solve a variety of broad business predictive tasks. It leverages concepts that you find within LLMs, such as attention and collaborative signal. This allows it to generate predictions that are highly accurate and effectively near instant. So let's see it in action. In this demo, we showcase a predictive decision intelligence agent built entirely on top of Snowflake and leveraging the Kumo AI relational foundation model for zero-shot predictions. The solution leverages Snowflake Cortex, Snowflake Semantic Models, Langchain-Snowflake, and Kumo RFM running in SPCS. What makes this demo unique is that all predictions come from Kumo RFM's zero-shot prediction engine. This means there are no separate models trained for individual tasks. As the user of this agent, I am a sales district manager at Acme Corp. I wish to understand risks in my current quarter, recommendations to guide my time and my coaching to de-risk and shape deals, as well as build for future quarters. This moves significantly beyond text to SQL into the work of predictive decision intelligence. The first thing I want to do as the sales district manager is understand what my current quarter looks like. My first question to the sales agent is, for this quarter, which deals are committed and what is their probability of closing? Rank them from most at risk to least at risk. The system returns my quarterly pipeline, categorizing each opportunity through a Kumo prediction into high risk, moderate risk, or low risk based on the predicted probability to close. Within seconds, I can see that several large opportunities are classified as high risk, while others look far more stable. This gives me a fast, data-driven view into where my attention should go this quarter. Next, I want to understand my forecast. As a manager, I know my reps often overestimate deal size within my CRM. So I ask, can you forecast the expected deal size for each deal, and then you calculate my total expected bookings for the quarter, broken down by sales representative? The system adjusts each deal size based on patterns in historical data and overlays the probability of closure to create an accurate bookings forecast. This forecast is entirely up to date based on when I ask the question, and I can provide such a forecast to my leadership during my weekly updates. Next, I consider the timing of our opportunities. Late quarter deals often place risk on the quarter. So I ask, can you forecast when each deal is expected to close and show me which ones are projected to close later in December? The assistant highlights one large deal that is expected to close late in the quarter, which immediately flags my attention and where I may need to intervene to bring it forth. Finally, I ask, how might I de-risk the quarter by pulling forward pipeline from next quarter? I ask which leads currently assigned to the next quarter could realistically be accelerated. The system thinks, but identifies 5 opportunities with meaningful probability of closing earlier if prioritized. This provides optionality. I now have a set of candidate deals I can strategically accelerate to protect the current quarter's outcome. Next, I want to take action on at-risk deals. Based on my prior questioning and analysis, opportunity 01841 was identified as having an outsized influence on my quarter. And it has a high possible deal size, but also a high probability of converting. If it does not convert, my outcome for the quarter will be largely different. I ask, why is the probability of closing so high? The system responds on the most influential contributors to the prediction using Kumo's inbuilt explainable AI features. For this particular deal, the high confidence is attributed to strong executive engagement, a reputable source for the opportunity, the sales qualified date. Furthermore, my most experienced and highest ranked sales agent is on this account. So I decide that this is maybe not a huge risk and I merely need to monitor. On the other hand, my prior analysis indicated 0111 or Stratus Group had a low conversion estimate. I want to understand why it has a low probability of closing, since I thought it was previously a high opportunity deal. So I ask about this particular deal, and furthermore, I ask what actions I can take to increase the probability of closing Stratus Group. The system returns prescriptive recommendations. It shows that bringing in an executive sponsor, adding a partner, and offering a small discount could materially lift the probability of success within this deal. Specifically, bringing in a partner had the most impact on increasing the probability. Taken together, these actions could materially raise the probability of this account. This is powerful. It's not just prediction, it's actionable guidance that quantifies the impact of each lever. Finally, I want to build for next quarter. I want to ensure that I'm already planning ahead so I have a great next quarter. And I ask, for next quarter, what is my early pipeline forecast and which deals should I prioritize? The Decision Intelligence Agent projects forward, showing both total expected bookings and highlighting the most important deals for next quarter. This allows me to start shaping my strategy well before the quarter begins. Finally, I ask, how can I grow the pipeline further? What actions will help me expand my Q2 pipeline? The system runs counterfactual scenarios. For example, testing the expected uplift from launching a regional account-based marketing campaign or conference. This forward-looking perspective means I can balance protecting this quarter while setting up a strong foundation for the next. This demonstration illustrates how a predictive decision intelligence agent powered by Snowflake and Kumo RFM can transform the way sales managers operate. Instead of only answering retrospective queries, managers can generate predictive insights. Instead of just probabilities, they receive clear explanations and recommended actions. During the demo, we formulated 8 different predictive queries, showcasing Kumo RFM's versatility across multiple categories of predictive tasks: classification, regression, forecasting, and recommendation. All on the same Snowflake Semantic Model and all without requiring any model-specific training. We also demonstrated how a single query can adapt seamlessly by adjusting input parameters, something that cannot be done with a traditional ML model. Lastly, queries can be entirely unseen and dynamically generated based on user intent. As long as there's sufficient data, Kumo RFM can make the prediction. This agent is entirely versatile and could be applied to any business domain and any use case with the appropriate data. Now we've seen the power of Kumo and our predictive intelligence agent, which we built on Snowflake. Let's take a look under the hood of how it was built. At its core, we've built an agent architecture that can reason over natural language input. The agent breaks down these natural language questions into two types of queries: retroactive queries, powered by Cortex and based on SQL, enabling it to retrieve historical insights, and predictive queries, powered by Kumo AI to forecast what comes next. These queries are executed directly on your data within Snowflake. Let's take a look under the hood at the code. Now we'll jump into our boilerplate notebook to outline the key components and steps we took to build our predictive intelligence agent. We start with our data setup. Here we have loaded several relational tables into Snowflake. These tables reflect common tables we'd find in a typical CRM, such as accounts, leads, and opportunities. We've also gone ahead and defined a Snowflake semantic view. This semantic view allows us to define key relationships between tables, along with other metadata the agent will use for predictions and SQL queries. We must also set up the Kumo RFM service, launchable as a Snowflake native app, ensuring no data ever leaves your Snowflake account. With all of this set up, let's dive into our notebook, describing our application boilerplate. We start with a few key imports first, most notably Langchain-Snowflake, what we'll use as our agents framework, and the Kumo RFM SDK. We define boilerplate to provide Kumo access to our Snowflake data tables, and the semantic model, priming the model for predictions on our data. With that, we're ready to start building our agent. Our agent follows a simple React agent design paradigm. React agents are common agent architectures that use two distinct steps, a reasoning step and an acting step. The reasoning step here is responsible for figuring out what the agent should do next, decide when a tool call or action is necessary, and finally, when to await further human instruction. For this demonstration, we are going to show the agent using three tools. The first is a SQL execution tool, which allows us to run SQL directly against Snowflake. The second is a Cortex analyst tool, which allows our agent to better understand human input and convert that human input to SQL or prediction query syntax. Finally, the Kumo RFM prediction tool, which allows us to run future-looking predictions against Snowflake. Let's define these tools, starting with the Snowflake query tool. This tool is a light wrapper around the Snowflake SQL query method provided by Langchain-Snowflake. Snowflake has made this very easy for us. Let's quickly run a test to ensure everything is working correctly. Here I'm going to enter a simple SQL command to query opportunities in our dataset. Great, the query has returned, and we see 2,000 opportunities returned in our dataset, confirming data access, and SQL is executing accordingly. Next, let's set up our Snowflake Cortex Analyst, our tool that converts natural language into SQL and prediction query syntax. To confirm everything's working, let's go ahead and run a simple query. This time, we're going to ask in natural language, how many opportunities do we have in the current quarter? This is a SQL query. Great, we see that it's taken that human natural language input and converted it into SQL and handed it off to the SQL tool. Finally, let's set up the most important, the prediction tool. The prediction tool is a wrapper around methods exposed through the Kumo RFM SDK. With this tool, We can create forecasts, risk scores, recommendation predictions, prediction explanations, and much more. Let's test it. To test, I wish to investigate if 2 important sales accounts as a sales manager are likely to convert within the current quarter, defined as the next 90 days. The output returns a table with the probability of closing for these 2 opportunities. Unfortunately, the probability is not looking good for these 2 accounts at only 20% probability of conversion. As a sales manager, I would want to investigate further. With our tools set up, we can now move on to creating the agent workflow. For reasoning, we need to define something called a system prompt that contains important context and prompt engineering to an LLM that takes the role of reasoning. This system prompt starts generically with "You are a helpful AI assistant," but then moves into more complex contexts such as details of each of the tools it has access to and example workflows that the LLM can use to learn the reasoning pattern it should follow when performing similar tasks. The agent core is defined in a class called Predictive React Agent class. Here, we initialize chat Snowflake provided by the Snowflake Langchain library to connect our agent to an LLM, in this case Claude, exposed via and internally within Snowflake. No data ever leaves Snowflake in our agent. Finally, the agent and reasoning and agent acting nodes are defined in our class. The agent state moves between reasoning, figuring out what to do next, acting, making tool calls such as predictions or queries, or waiting based on for the next round of human input. These state changes between these nodes are defined by edges within our agent graph. Lastly, in our agent, we create a simple invoke function. Within here, this invoke function called chat takes the user natural language human prompt and passes it along with the system prompt to the reasoning node on any new input, initiating an agent workflow. Everything's in place. Let's go ahead and test it. I'm going to ask in natural language, fetch the top 5 opportunities by deal size within the current quarter, and return their likelihood of successfully closing. On the outset, this looks like a simple query, but let's break it down. The first part of the question actually requires fetching the top 5 opportunities by value. This is a SQL query. But the next part of the question requires passing these accounts identified from the SQL query into a Kumo prediction query. This is a 2-step query. The reasoning node is able to break down this complex task into several act calls, breaking the questions into first, 2 sequential queries, 1 SQL, 1 predictive, rewriting the human queries into SQL and Kumo predictive prediction query syntax, executing the queries in turn, and finally summarizing the results in a natural language output that's more interpretable. Terrific! Our agent is able to perform this complex multi-step task and is able to predict the probabilities of these accounts, all via a zero-shot foundation model. Here I want to stress no training has ever happened on this data. This data has never been seen by the Kumo RFM model, and this query has never been seen by the Kumo RFM model. This is fully zero-shot and can be generalized to any query on the semantic model. If we want to dive deeper into the response, the full response output from each agent step is output in a return object that we can inspect by printing it to the screen. We've achieved a lot. Furthermore, we want to stress that this is simple boilerplate. Our real agent is significantly more complex. Things we would want to do next here would be refine the text to prediction SQL parsing, add the explain RFM tool, enabling Kumo RFM to provide explainable AI on the predictions, adding memory to the agent so that the agent can reason on the full message history. Of course, we would need to build an intuitive UI for interactivity and ease of use. And lastly, we want to do a lot of end-to-end testing to to ensure robustness. On this note, let's wrap up this technical deep dive here. Now we've explored how our agent works and taken a look in depth at how we built it. I want to stress that this type of agent is not just applicable to sales or marketing. Over the past several months, we have seen this technology and Kumo help businesses apply this technology to all verticals. We have seen applications and agents in healthcare, supply chain, marketing, and sales. Here is but just a short list of use cases and agents we have seen. Thank you for watching our demonstration today. To learn more and get a copy of our notebook or see a more in-depth private demo, please visit us at Kumo AI. We have a lot of information there. There's also options for free trials and an option to contact us. Thank you, Snowflake and the build team, for organizing this event.